Okay, so for my project, for the prototype, I did a harp, and it differs a lot from my patent because it was a lot of trial and error, which I'll talk about. Here's the back view of the harp. Here's the back view on the patent. Here's the front view on the patent. Front view of the harp. This is the top view of the patent. This is the top view of the harp. Side view of the patent. This is one side of the harp. This is the other side of the harp. So now that you've seen the visual differences between the patent and the harp itself, I'm gonna go over how the prototype was made differently, or why it needed to be different. So one problem I faced when trying to create a prototype for a harp is that I needed a soundboard, which meant I needed a hollow area for sound to be able to vibrate, and openings for the sound to be able to resonate and then come out and have a bigger sound. So I had to ignore that I had 3 openings in the board because sawing circles is beyond my ability in carpentry. So here's what I did. Instead of cutting holes like in the patent, I made one small hole at the bottom, which didn't connect all the way to these 2x4s here, so that the sound can still vibrate around, and there are slight cracks here for sound to still come out. So if you were to look at the harp from a top angle, you'll be able to see that it is a hollow box inside. You can see the soundboard itself, where the strings are attached, is here, and then everything else is hollow, so it gives space for sound to move around. Another carpentry barrier that I had to overcome when making this harp is that I'm not able to carve curvy pieces of wood. So instead, I had to adapt and make it out of a straight piece of wood for the arch. So it's not an arch anymore, really, but it's an angled piece of wood that connects to the column. This is the original design and the curvy arch. This is my adapted design, and at the top there's a 30-degree angle between the pillar and the piece of wood, and these are both cut to the same angle here and here. Because I didn't have that perfect curvy cut piece of wood, I had to make another adjustment and create a little triangle at the top of the soundboard. Cut at 30 degrees again, or 90 leading up here. Cut at basically a 90-degree angle, a little bit spotted, but this is so that this arch, quote unquote, can connect from the soundboard itself, screwed in the back, to the pillar. My patent originally stated that I would use nylon strings to make the strings themselves on the harp, but instead I ended up using the Berkeley Trilene Big Game 30-pound fishing line as my string. Fishing line instead of nylon strings for a couple of reasons. One being that nylon strings are very expensive and come in fewer quantity than fishing line. Because my soundboard is way too thin to hold nylon strings, so we had to go for a thinner alternative. As far as tying the strings themselves onto the soundboard without having it come through the hole, I had to use a classic harp knot. So I will give a tutorial on that. Okay, so you're gonna need 3 pieces of equipment, I guess, to make this. So I'm gonna use I'm gonna use this fishing line here that I'm using as strings instead of nylon. And then I found a thicker type string. This is from a like long clipper cartridge. So, and then you're also gonna need clippers. So you're gonna clip a part of the thicker piece of string. This will be called your toggle, and this will come into play. Next, before you cut the amount of fishing line you need, you're gonna find the end of the string and make 2 little bunny ears, like this. And then you're gonna put one bunny ear into the other, and then pull. And before you pull all the way, you're gonna put your toggle into the middle here, and then you're gonna pull with fingers like this, like a bow and arrow. And then because we're using quite thin wood, we're gonna double knot, so we're gonna make another bunny ear and put both the toggle and the loop into the other loop. So now you have come out with this tie for your harp string, and it should work for all of them. One mistake I made on my pattern itself is I used such a small scale, so I obviously did not stay with a 5-centimeter soundboard. Instead, we were at 2 feet, so I had to change some of my lengths according to reality. So for reference, for size of the wood, I have this ruler here, and this bottom piece is cut to 1 foot. And we have cut 2 pieces of this 2x4 and stacked them together to create a sound base for the harp itself to be able to stand on, because it wouldn't be able to stand by itself without any support through the middle. And given the lack of space in the middle, we decided to create this support from the bottom. For the pillar, we used 2 wood post toppers, and we screwed them together and then put this cylinder, which is about 1 inch in diameter, connecting all the way to the top. The cylinder itself is about 2 feet long. The soundboard connecting the strings is about 22 inches long. And as far as the spacing goes between the strings, they're about 1 inch apart, and this line that they were drawn from is the exact middle of this board. So about 2 inches. This next part was probably the most challenging part of building this. I had to figure out how to create tension from connecting it from the soundboard into the arch. This was the biggest challenge because when I would originally tie the string and ring it to the tension, I used to have little screws with holes on the ends that I would use. These. But once I got to my right tension, it would snap. So that would mean I had to take off the soundboard again and refix everything. So after much trial and error, here's what we came up with. I decided to keep it simple and keep all of the strings 1 inch apart on the soundboard. So it's going to correlate with how they're set up on the top. So they're all 1 inch apart up here, and then about 3/4 of an inch apart with the screw attached at about a 12-degree angle. And these are also 1 inch apart each. Tying the string on was difficult, but we found that if you tie this 2 times here and then 5 times here and then screw it in, it increases the tension into the arch. You can apply physics to this because the lower string has a lower frequency and the higher string has a higher frequency. This means that there are more oscillations per minute in the higher string because you can't see it move as much. Whereas this one, the lowest one, has a higher, or a lower frequency, sorry. This project, the Harmonic Harp, is a good example of harmonic motion because if you're plucking a string, you're using force to push or pull an object toward equilibrium that is proportional to the displacement from equilibrium. So not only does it have the alliteration, but it's actually also harmonic. As a disclaimer before I play the notes that are on this harp, this is a prototype and the final product is soon to come and is perfected more than this. As far as similarities between my patent and my prototype, or final product for prototype, is that the technical field pretty much stayed the same. The frequency generation, this is from my original patent, the frequency generation comes from the standing waves departing from the string when plucked. This frequency varies due to different strings, tensions, or the notes, and the string makeup, whether it is nylon, gut, or fishing line, and the length of the string in general. The soundboard is where the vibration produced can run freely and amplify. All of these components are still true, going from patent to prototype, so the technical field has not changed. The intended usage differs a little bit. So my original was that the typical pedal harp obtains 47 strings all mixed with differing lengths, tensions, and makeups, and I faced the problem with not being able to make a harp with 47 strings or with pedals to be able to change them to any note. So I have simply like 14 strings, and you're able to change the note by turning the screwdriver. So that's the intended usage. It has turned from having all of the notes there to having a couple of them and being able to alter some of them. So overall, this project took a lot of time and effort, just like how I thought I would in my construction in the patent. And it took me 3 days to make, considering there was painting, wood prep work, drilling, sanding. So there was a lot that went into this project that I didn't expect, but I feel like it turned out the best I could have made it.